Well, let's do a similar kind of calculation to find the transfer matrix for the thin lens. And I'm going to consider, first of all, the thick lens. Ultimately, we'll let the thickness go to zero. Uh, I'm, I have two spherical surfaces. I'm going to have this one in air, so index refraction N1 on this side, N in the lens, and N2 air on this side as well. Um, the way I have it drawn, well, R1 would be positive and R2 would be negative, but let's just keep them generic as R1 and R2 as the radiuses of these two spherical interfaces. And what I need to do is find the matrix transfer matrix for this whole system, starting at the front, uh, going through the interface, then through the translation through N, and then through this interface to where it emerges on the other side. And the way I actually write these when I do these is I move from left to right, and I write this in terms of matrices and from right back to left. So the first thing I put down here, a light beam comes over here, it's going to hit R1, and so that is the refraction at the first interface. Then it's going to have to be translated in a homogeneous isotropic media over to here, and that's this translation by a distance t. And then finally it has to get from one side to the other of the second interface, and that's another refraction matrix. So in general, you build up um, the optical system matrices in this way. You progress from left to right, but when you write them down, you're writing them down from right to left to get the whole thing. To to use our previous results, which we can do now, we know what the refraction is at the first surface. It's 1, 0, minus N2 minus N1 over over N2 divided by the radius, and then uh, N1 over N2. And for us, N1 is 1, that's here. N2 is N. Uh, this is minus N2, N minus N1, 1 over N2, R1. Once I've got on the other side, now then I can translate it by a distance t to get over to the interior on this other side. And if you remember a couple of videos ago, we got that translation matrix is 1 times the translation distance, 0, 1. So that's the translation. And then finally we get through to the other side. And again, that's a refraction, but now it's at the second interface. It's the same formula. It really is minus N2 minus N divided by N2, and then N1 over N2. But remember, N2 is 1, so we get minus 1 minus N times 1, or divided by 1 times R2. The second one is N2. And then the side over here, N1 was N and N2 was 1. So we now need to multiply these matrices out. What I'll do first of all, though, is I'm not interested in the thick lens, although I could have a thick lens by multiplying it out. It gets a little bit messy. Uh, but you can certainly do that. But now I'll let t go to 0 once I've computed this, or once I've got it in this form. So if I let t go to 0, there's no t's here or here. The only place there's the thickness of the lens involved is here. And if I let that go to 0, it simply becomes the identity matrix. And so I can, identity matrix times any matrix just gives me the matrix back again. And then it just comes down to multiplying these two matrices together. If I do that, I'll get 1 times 1, which is 1. 0 times this one is 0. I'll get 1 times 0, 0 times 0, so 0 up here. And then this one I'll get minus this quantity times 1, so that's minus 1 minus n over R2, times this quantity times this one. And that the n's go away, and that just becomes minus n1 over R1. And then finally, the last one becomes 0 times n or plus n times 1 over n, which is just 1. So at that point, really you just need to clean that up a little bit. What I did was I pulled out n minus 1, and when or a minus n minus 1, so I pull out a minus sign on all of this, and then an n minus 1, and that'll flip this one to be a minus 1 over r. But if you remember, the Lensmaker formula was just 1 over the focal length of a thin lens is n minus 1 times 1 over r1 minus 1 over r2. And so this quantity here is nothing more than 1 over f. And so for the thin lens, we get a particularly simple expression, namely that the transfer matrix is just 1, 0, minus 1 over the focal length of the thin lens, and a 1 here. Well, we'll use these in some additional applications a little bit later on, and certainly you'll need these expressions for your homework. Your book has a nice table, and you need to make sure that you read through the sections that are listed on with this lecture, and make sure you read those carefully. And in particular, I'd probably get used to using that that table that's there listed in your book.